And so we believe we'll be able to compress the time to build a house from scratch just in a couple days. With Monumental, we're trying to fundamentally solve the big problems in construction by making it fully autonomous with construction robots that can autonomously build buildings faster, cheaper, and more beautiful than what we can do today. You walk around a European city or even old American cities or elsewhere, and you just see beautiful cities that have been built hundreds of years ago, right? There's craft in there, they're beautiful, and we did it when we were so much poorer. Our mission is to make that possible again. I think it's actually just a tangible thing that has just been lost in the pressure because we have a housing shortage, so we just build whatever we need to do, so we can't actually afford even to build these nice things. I think that will change if we succeed. The problem in construction is it's such a tacit industry, meaning that a lot of knowledge that sits in people's heads is the cause of a lot of problems. The estimates are something between every construction project, 10 to 15% of the cost is just mistakes that were made. If you want to introduce robotics, you actually have to make the process more well-defined. And the way to do that is to model everything in software, which is something we think we're actually good at. As you can see behind me, we have one bricklaying robot that's does the actual bricklaying. But we discovered very quickly that a big part of construction is just getting the material there. At least 25% of the work is actually just moving stuff around in a wheelbarrow. So we built a brick supply robot as well that brings the bricks, and a mortar supply robot that mixes and brings the mortar as well to the robots.
At this point, we are building 3 different types of robots. This is our wall building robot. Pisa has 2 cranes, and on each crane there are arms with attached end effector. For example, this one is called hopper, and it's for our mortar. And here you have an arm with a gripper, which is building walls, basically.
Behind me, we have a bunch of April tags. They look like QR codes. Basically how it works, we have some cameras on the robots. The cameras, they see these tags, and they use several tags to estimate their position. So this is the first step here. We're refilling our hopper with mortar from our mortar supply wagon. The next step is applying a mortar to the bricks. So we call this our lick and stick system. So this crane basically applies an even layer of mortar on the bricks before a brick is placed down. This is our brick supply wagon. It has a number of bays along its sides, on each side. In the middle, it has a brick elevator. The brick elevator takes the upmost brick from any of the bays, and then it transports it to the front, where it's put on the platter, so that the gripper can then lift it from the platter. This is the interface that all of our robot operators see while they're working with the robot. And while they're doing this, everything that they are doing is logged. We get how well the brick was placed, either automatically detected or marked by the operator. And this is really key to allow us to iterate fast. So it's a very software-centric approach. We're logging everything, and then when our software engineers need to fix something, they know they have everything they need.
So for every brick that we place, we track a lot of data. This is our wall inspector that we use to analyze a brick. So on the right, we can see the photos of the brick as it's being picked up, as its shape is being detected, as it's being placed into the wall.
I think the thing that people don't really appreciate about what's really interesting and unique about construction from a robotics perspective is almost every other robotics use case I know, think about warehouse logistics or baggage handling in an airport or something like that, are pick and place problems where the things go in the same location. In construction, nothing can go to the same location, and where that new location is not an easy problem, because the obvious one is you go next to the previous brick, but you have to know if there's going to be a door. You have to keep a 1 meter gap suddenly. Knowing where to place things requires you suddenly to have this very deep understanding of everything that goes into a building. Our two most important operating principles at Monumental are speed and getting ground truth, and they actually go hand in hand. So speed means it's important in every startup, but I'd say it's the most important thing for a hardware startup to not fail, which is why we've engineered everything from our culture, but even if you look behind me, 3D printers everywhere to allow for rapid prototyping, and so that we can move really fast. And we ship hardware on a weekly basis, which I think is pretty unique. But of course, if you ship hardware on a weekly basis and you're just like testing in a vacuum, that doesn't teach you anything. So you need to test it on a real construction site and getting that ground truth in the real world environment. That's what matters. And those two things allow you to move so fast and, in my view, like succeed much faster. I think what's most exciting about the phase we're in today is the fact that we're on construction sites as we speak. So you can see the dashboards live here, over here, where you can see like live video streams, telemetry of what we're doing on site. We're currently, as we speak right now, on 3 different construction sites, which is really exciting that we have like a robot fleet building things right now in multiple places in the Netherlands.
I've worked at Monumental since November. I think a lot has changed in that time. I mean, when I started, we were doing just one deployment and we were working with masons to get that couple of buildings finished. And then now we've managed to do like 3 deployments at the same time. And also we managed to do a deployment like all by ourselves, no masons required. We did all the brickwork for one building. So that's pretty sick.
So what's unique about us is we actually don't sell the robots. So we are a subcontractor. We sell the walls today. And so the way the industry works is you have like the real customer, the person who wants the buildings. They go to a general contractor, but the general contractors in most countries today, they're not vertically integrated. So they subcontract almost all the work. They do like the project management and the planning and the permitting, but they will go to someone to do the plumbing, and they will go to someone to do the roofing, and they will go to someone to do the brickwork or the whole facade. And so we plug and play into that model. But of course, the big difference is we don't show up with people, we show up with robots that will do the work. So the exciting thing about the approach we're taking with Monumental, and what allows for like a very exciting future vision, is we're building these small modular robots. And so you'll be able to swarm a lot of them, right? Just like with drones and warfare, how that's changing. We'll do the same thing for construction. And that means that if you want to go faster, you can just deploy 10 or 100 of them and build a house in 1 or 2 days in the future. Where I'd like to be in 5 years is that we actually have already started to attack adjacent product lines. But where I think we're going to be is trying to do the entire facade in an automated way. So if you think about the entire facade, it exists of concrete or limestone blocks on the interior. There's insulation, there's like windows, there are lintels, the things that go on windows and door frames. Like there's those things. And if you've done all those things, you've actually, I think, you've delivered a very valuable product, building the entire kind of like exterior facade of a house in an automated way, where all these things actually like compound together, right? Because you're doing all these trays together. I think that would be like a very exciting place to be in 5 years.